forgot to start recording. Here we go. We're shifting at right 8. So again, that's horizontal. So to the x's, I'm going to go add 8. I just took care of that one. What am I doing to the y's? Subtracting 3. It's going down 3. So can you guys do that math and tell me what my 3 ordered pairs I need to graph are? Okay.
8 minus 3. I mean, x
Negative
8.
3.
3y.
There we go. Okay, good. I was like, wow, do these children really not know how to like add and subtract with negative numbers? Y'all were scaring me for a second. So all you have to do is go graph those 3 points and you're done. Did you get it right? I'm so proud of you. It's not hard, but it's different because no one has shown you tables before. This is really how you should have learned it in previous math classes. Totally okay if you didn't. I'm showing you now. All right. But if there are horizontal stretches, compressions, especially if there's horizontal and vertical, you need to make tables. Okay. All right. So 8, negative 1, 2, 3. I know a lot of you don't like graphing, but we're just practicing. 6, negative 5, and then 0, negative 7. And when I connect them, it should look like that. All right, we're going to check ourselves. Are y'all ready? Yes? Great. What should a square root function normally look like? What does the parent look like? Show me with your hand or your finger. Okay, good. Everybody's doing this in here. Kind of looks like that, right? I know that's not completely accurate. Is everybody good with that? Okay, so now go check your equation. We stretched it vertically and stretched it horizontally, so it should look bigger in general. Does it look bigger? Okay, good. Now there was a vertical reflection, which means instead of facing up, it should be facing down. And then there was also a horizontal reflection, which means it should also now be facing the left. Does it look like this? Yes, okay, that looks good too. And then look at your equation. Our initial point should be at 8, negative 3. Did we start it at 8, negative 3? So that's an easy way to check yourself. Go check for your reflections. If you stretched it, it should look bigger. If you compressed it, it should look a lot smaller. The points should be a lot closer together. And then check your initial point for your shifts, okay? Do we feel better? Okay, good. All right, on the homework. Can we go over homework now? Okay. People at home are okay?
Yes.
Okay. Which ones off of the homework do I need to do? I know number 2. Does anybody need to see number 1? Y'all sure? Because y'all's number 1s looked a little off.
Yeah.
Can I just go ahead and do it? Is that fine? I'll do 1 and 2. Do I need to do 3, 4, 5, 6, or can y'all just check mine? You can just check them? Ah! Okay. I'll look at it later. Are we okay? All right, so I'm going to do 1 and 2. Do y'all want me to do those first, or do you want to check 3 through 6 first? 1 and 2 first. Okay, look at your equation for number 1. Are there any horizontal stretches or compressions? So do you have to do a table for this one? No. Can you do a table?
Yeah.
Sure. Does anybody want me to do tables, or do you want me to just use the A value? Just use the A value? Okay. If anybody wants tables, speak up. So really quick, state the parent function. What is it? Thank you. Thank you. Ooh. All right, f of x equals x cubed. Now it says describe the transformation. So talk to me, what do we got? Okay, up 2, love it. Left 1, good. vertical reflect, and then I also heard vertical compress by how much? Good. Everybody okay with those transformations? All right, so let's review from graphing when it's just vertical. Where should my initial point be? Okay, it should be at 0, 0. Good. Where did we move it? Where did we shift it? Left 1, up 2. So I heard -1, 2. That's your initial point. -1, up 2. Here's my initial point right here. Zoom it in so y'all can really see. All right, now to find the other 2 points. This is a cubic function. So does everybody agree that the x's are 1 away from the middle point? Because it's -1, 0, 1, right? So that means I can go over 1 in each direction for the x's. And then how much am I going to go up and down? A third, because we are pressing it down by a third. So I'm not going to go all the way up to the next one. I'm only going to go up or down a third. Are we okay with that? If I vertically reflected it, which side should be pointing up? The left, because it's negative, right? So watch this. You're going to go over 1 and then up a third. So it barely goes up on the left, because it should be up on the left because it's negative. Then for the right side, I'm going to go over 1, down a third. And there's your 3 points. I know it's hard to see, the graph is small. Good. So -1 to 0, the distance is 1, right? For the x values. So I'm going to go left 1, and then 0 to 1 is the distance is 1. So I'm also going to go right 1. Exactly. Did you guys hear what she just said? We can do that because there's no horizontal stretches or compressions. When there's no horizontal stretches, compressions, you can go over 1, up and down. Are we okay? People at home, y'all are okay?
Yeah.
You can do tables if you like the table way better. You would just do this. So we're multiplying the y's by -1/3. And then we're subtracting 1 from the x's, and we're adding 2 to the y's after we multiply by -1/3. You could totally do a table to check yourself, okay? All right, let's look at 2. What do you guys notice about number 2? Okay, there's a horizontal stretch or compression, which means we have to put it in what form first? Factored. So this would be the square root. Take out the -9. What am I left with in parentheses? Good. X minus 2, and then minus 4. All right, so transformations, talk to me. What do we got? Down 4, good. Anybody else? Hang on. What did somebody just say with the 2? Right, 2, okay. And then what did you say, Chris? Very good. Horizontal reflection, because that 9 is negative. And then since it's a 9, it looks like it'll be a, so what does that mean it really is?
Compression.
Good. Horizontal compress. Kevin, I miss you being in class. Can't wait to see you next week. Horizontally compressed by 1/9. He answers everything so calmly. And y'all let me skip it. Parent function is square root of x, right? Okay. All right, now, since we have a horizontal compression, what do we need to do to graph it? What do we need to make? Tables, good. So look, what's your parent function for a square root? Good. You guys notice I keep giving you square roots? Have you noticed that? Okay, good. All right, and then we just read it left to right and perform those transformations. So the very first one I see is this -9. It is inside, so what variable is it affecting? The X is because it's a horizontal compression by 1/9, right? So you need to come multiply your X's by -1/9. That's the only multiplication. Do y'all agree? Yes? No? There's no vertical stretches or compressions, right? Okay. 0 times -1/9 is 0. 1 times -1/9 is -1/9. 4 times -1/9 is -4/9. Very good. 0, 1, and 2. Have I lost anybody? This one's tricky because it's like a 1/9, which is very, very small. Do you think I would give you the one that small on a test? Heck no, because y'all's graphs, some of y'all's graphs are worse than mine. I will not give you a number that small on the test. Okay? All right, now, only two I haven't dealt with are my shifts. So what do I need to add or subtract to the X's? Ooh, good, +2. Remember your X is the opposite. Very good. And what about the Y's? There we go. All right, are y'all ready to hear the biggest lie you were ever told in middle school, and maybe even math 1 and 2, depending on who you had? They told you would never use mixed numbers. Yeah. That is a lie. It is very hard to graph an improper fraction. You would much rather have a mixed number or a decimal, okay? Because if I tell you that this is 14/9, what the heck is 14/9? Where does that go? You get what I'm saying? So just leave it as mixed numbers, okay? 2 plus 0 is 2. -1/9 plus 2. That's just 2 minus a 9th, right? So that would just be 1 8/9. I'm scared that some of y'all look so confused by that. We okay? Okay. 2 minus 4/9 would just be 1 5/9. Then my Y's are going to be -4, -3, and -2. So that is what you need to graph. And that's going to be really hard to graph, isn't it? But we're going to do our best. All right, so 2, -4, write 2 down 4. There's my initial point. Then 1 8/9 is really, really close to what? So I'm going to get as close to 2 as I can without touching it. And then 1 5/9 is right around 1 1/2. Because 4/9 is right under a half, right? So I'm going to go about halfway down to -2. There's my point right there. And connect them. Now let's talk about what you guys had on your homework. A lot of you guys had the points really, really far apart. Look at your equation. We are pressing this graph in by a factor of 9. So that means we're taking those points and we are pressing them in pretty much as close as they'll go. So your points should be very close together, okay? If we reflect a square root horizontally, do y'all agree that the parent function should look like this? Should point to the right. So if I flip it horizontally, it's now going to point to the left. And then my initial point should be at 2, -4, which it is. So that all looks good. We feel a little better about graphing. Okay, you're gonna do some more graphing today to practice. But the biggest part of our practice is looking at the graphs and writing the equation from that, because the past 3 years, there's always been at least 2 of those on the pre-cal exam, okay? Y'all feel good? All right, I'm gonna shut up for a second. Check 3 through 6. If you have a question, just ask me. A lot of y'all's 3 and 4s looked really good though. Yes, I got 2 questions. Ross first. What's up?
Number 2, gave you brackets for the factor one, but you did for 4.
Good. So for 4, I used brackets. Lord Jesus, I didn't put squared either. Y'all got to call me out on that. I used brackets for this one because check this out. Is everybody watching? The -2 also has to be squared. So a lot of y'all on your Delta math quiz left it answers like this. Those aren't the same thing. This one is only squaring the x minus 5. This one is factored form because you are squaring the whole thing. Now for number 2, I didn't have to do that because it's all underneath the square root. So I know I'm taking the square root of the whole thing. Does that make sense? If there's an exponent, you're going to need the brackets, okay? All right. Was that your question, Chris? Oh, cool. Yes, ma'am. The 1 8/9? Yes. So, okay. Let's see. We're going to go back. Way, way back. Ew, that's disgusting. Miss Garris had some nasty stuff in her classroom. What the heck is that? And I'm wearing white pants. Goodbye. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretend I have 2 groups of these. You ready? I don't have enough to do 2 groups, so just watch. I have 2 groups of these, and then I take away 1/9. I still have a whole group, but there's only 8 out of 9 in this group. Sound good? I should have been an elementary school teacher. I love stuff like this. All right, so then the next one, 2 take away 4/9. This is still a whole group, so that's where the 1 comes from. 1, 2, 3, 4. There's 5 in this group out of 9. Cool? You're welcome. Y'all good with 3, 4, 5, and 6? A lot of y'all had not the right stuff for 5 and 6. If we shift, Lord Jesus, shift it left 5, that means we're adding 5, because remember your x does the opposite. If we shift it right 5 for the next one, that means we subtract 5. It would be at 8. Cool? Are we sure? We're cool. That's okay. It's okay. I could tell that that's what some of you did. Some of you did the wrong operation though. All right, so there were 2 on the homework we did not do, correct? It's because we didn't get to them in class, which is not a bad thing. I want to do these with you. So these are like part of your notes, okay? Oh God, that one has stuff written on it. Waste another sheet of paper. Here we go. All right, this is what I was talking about yesterday. When you are given a graph, you don't need to check horizontal and vertical. Check one or the other. All right? Because in an idealistic world, look at me for a second. The ones like the warm-up, except this is not a great example. Let me do one like this instead. Look up here real quick. What happens with that 2.5? Good. Say it again, KJ. They're inverses. They're reciprocals of each other. So when we multiply them, it just becomes 1, right? So when you are checking a graph, I need you to understand that you check vertical first, because I feel like you guys are good with the vertical transformations, right? Because you're used to those. Check vertical first. If you can't find the vertical stretch or compression, then check horizontal. Write that down. This is going to serve as like your notes for the graphs. And then all you are doing today in class is practicing these. And then your homework will be to practice graphing. Okay? So we're going to check for a vertical stretch first or compression. If we can't see what the factor is vertically, then you check horizontal. Are we okay with that? Yes, no, yes. I saw yeses. Okay. All right, so talk to me. What's the parent function for number 7? What kind of function is this? Absolute value, good. So this is the absolute value function because it's a v, right? Okay, where does the absolute value function normally start? 0, 0. Where does this one start? 2, 1. What the heck is that? Eric, are you hacking me? You didn't see that, did you? Eric likes to hack, y'all. All right, so if it's at 2, 1, I moved it right 2, up 1. Sorry, Eric, I just gave your life away. Not in a bad way. He's going to work for the CIA one day because he's that smart. He's going to hack into bad people's stuff. When you make it that far in life, will you give me a shout out? Be like, I owe some of it, like maybe 5% to my honors pre-calculus teacher. Okay, cool. All right, right 2, up 1. Are we good with that? So now the only other thing we have to check for is a reflection, and then was it stretched or compressed, right? Now y'all look at this V. Was there a reflection? No, it's still facing up, right? And it doesn't matter if we flipped it left or right, because either way it still faces up. So we don't have to worry about a horizontal reflection. Are we okay there? So it would still look the same. Really, if we reflected it horizontally, it would be in quadrant 2. Sound good? Right? Because if you reflect horizontally, some of you just stared at me, it would be over here. Okay. We're good? All right. So how do you check for a vertical stretch or compression? What about the table? Me and you just had this conversation earlier. What's the distance? What's the distance between the middle point? 1. Thank you, Chris. Woo. Go to your middle point. Go over 1. How much does this one go up? A half. Very good. So what did we do to it? What kind of compress? There we go. Okay, good. Vertical compress by 1/2. Are we okay with that? Okay. Do you even need to check horizontal? No. I'm going to show you why in a second. So first of all, let's write our equation based on these transformations. What would my equation be? 1/2. Oh, yes. Look at y'all. Going to do good on this test. We're not going to psych ourselves out. A lot of y'all play sports, so I'm not quite sure why y'all psych yourselves out. You know not to do that. You gotta, even if you don't know what you're doing, you gotta fake it till you make it, okay? My very first year teaching pre-cal, I faked it till I made it a lot. Taught some stuff wrong, it's okay. It'd be like that sometimes, that's how you learn, all right? Now, you do not have to write this. I want you to watch. So everybody understand, I need your eyeballs right now. Let's say that the graph was a really crappy graph and you could not tell that this went up a half. Here is how you would check horizontally. You ready? Does everybody agree that horizontal and vertical are just opposites?
Yeah.
Okay, so for vertical, we go over 1. We're going to use that distance for horizontal, but instead of going over, what do you think we do for horizontal? Oh, up or down. Good. Just depends if it's positive or negative. This one's positive, so I'm going to go up. So everybody check this out. When you go up 1, how many does it go over? So this means you could say there's a vertical compressed by 1/2, or there's 2 different answers for this one. They both mean the same thing, so I want you to watch. Or we could say there was a horizontal stretch. Why did I write compress? Stretch by how much? Good. Now let's talk about it, because some of you are like 2. That's not the same as 1/2. If we horizontally stretch it by 2, remember your equation says the opposite. So what would the equation for that say? Ding, 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 1/2. Those 2 things are going to end up being the exact same if you solved them algebraically. Vertically compressing by 1/2 is the exact same as horizontally stretching by 2.
Wow.
Are you mind blown?
Yeah.
He was about to say, hell yeah. Okay. Are we okay? Do you understand now why I'm saying you don't need to check both? If you write down that there were both of those things, what did you just make them do with each other? Ding, ding, ding. Can you say that again? If you say there were both of those, you just made them cancel out. Because vertically compressing by 1/2 is the same as just stretching it out by 2. Either way, they're both getting wider, correct? This gets wider, this gets wider. It's the same. It's the same. Chris, I'm going to give you something you can press in either way, and you'll see it's the same. Cool? I have something. All right, let's look at 8. I hope I blew your mind just a little bit, but not too much. I need you to know they're the same. You do not need to check both. Is everybody good? Okay, we're good. Online people, are y'all okay?
Yes.
All right, so check this out. What kind of function is this one? Square root. Very good. It looks like the little hook, right? Now, off the beat, I see that this one goes up into the left, which means we reflected it. Now, freeze. It normally goes up and to the right. If I reflected it to go up and to the left, what kind of reflection would that be? Horizontal. I didn't change the up part. I didn't change the vertical part. I changed which direction it's going. That is horizontal, okay? So there is a horizontal reflection. You okay? Are you sure? Are you sure? Okay. All right, where does a square root function normally start? 0, 0. Where's this one hanging out at? Where's the initial point?
3, 1.
So how did I move it?
Right, 3 up.
Very good. Man, I remember when I showed you these Tuesday after your quiz, and y'all were like, I've never seen this before. Look how good you're doing now.
Yeah.
Learning. Hashtag learning. All right. Only other thing we have to check for is what? Stretch or compression. Which one is easier for you guys? Yeah, you should be used to vertical. So let's go over 1 and see how many it goes up or down, right? All right, find your initial point. I'm going to go over 1. How many does this one go up? So what did we do to it? Good, Drake. Stretched it by 2? Because it's supposed to go over 1, up 1, right? So if it goes up 2, we just stretched it. If it only goes up 1/2, we pressed it down. Can y'all write that equation? This is where you say, absolutely, Miss Poole. Or just keep ignoring me. I'm not gonna have enough room. I need to turn this. Thanks, Drake. All right, what do we got, children? What's my equation?
Y equals 2 square root negative
Yes.
x minus 3
Yep.
and then plus 1.
Yes, ma'am. Extra credit, Ross and Drake. Heard all three of you. Beautiful. Are y'all okay with that?
So when it's a horizontal reflection, you put the negative on the inside of whatever.
Very good. When it's a horizontal reflection, the negative should go inside whatever the function is. The absolute value bars, square root, brackets, whatever. Good. Yes, ma'am. Absolutely. Could you write it not in factored form? Sure. You could simplify it to standard form if you wanted. When you are graphing, it better be in factored form so you can see the shift, okay? Yes. Yes. What would we do? Talk to me. I was hoping somebody would be like, all right, can we try the horizontal just to see if they really do cancel each other out? Yes. Sorry, I got really excited. It was a good teacher moment. What do we do? To check for a horizontal one, if you didn't want to do vertical, if you wanted to be a smarty pants and do horizontal instead of over one, we would go up one. So y'all check this out. When you go up 1, 2, 3, there's 4 tick marks, right? Look at your graph. And it goes 1 out of the 4 over, which means it goes over 1/4. Does everybody agree with that? It goes over 1 out of the 4. This would be a hole over here. It only goes over 1. So 1 out of 4. Do you see that? Okay, y'all looking at me weird. So that means we compressed it by 1/4, right?
Yes.
Rodney, are you okay? Are you just trying to see it?
No, it really don't look like it goes up.
Right, it goes up 1. That is just how you see what the compression or stretch is. You just worry about the over. Okay? So we pressed it by a 1/4 because the next one only goes a 1/4 of the way in. It's horizontal, so what should the equation say? Not a 1/4, but what? 4. So y'all watch this. If you did it horizontally, the equation would be -4 parentheses x minus 3 and then a +1 on the outside, right? You ready to be mind blown? Sure. What's the square root of 4?
2.
Isn't that what you just wrote up here? It is. Just turn your head sideways. The purple and the pink match. So this is just me showing you, do you check both? No, they will cancel each other out. If you want to check both to check yourself, by all means do it. But don't tell me there's a horizontal and a vertical stretch. No, there's not. Y'all feel me? Sure. So listen, this is what we're about to do today. I'm going to give you roughly 20 minutes. I'm giving you this worksheet. People at home, I do not need you to turn this in. This is for you to practice reading the graphs and writing the equations. People in class, we're not turning this in. In 20 minutes, I'm doing any of these you want me to do, and I'll post my key. Does that sound good?
Yeah.
Yes. People in class, people online, you can stay on, and that way if you have a question about one, I can do it with you right now, or you can get off and just come on to go over the answers, okay? This is not homework though. This is not what you're turning in.